Hello, everybody. Very excited to introduce Shashwat Jain. He's a software engineer at Amazon and is going to be giving an interesting talk about agents and Amazon's platform. So I'll leave it to him and give him a round of applause.
Hello. Okay. Sorry, just checking the mic. Good morning, everyone. I'm Shashwat, and I am software development engineer, being in this industry for almost more than 10 years now. And the past few years of my life has been looking forward to it, looking into this particular thing. Whenever traffic come to a website, it's not only e-commerce platform. Even in my personal time, in my hobby projects, I'm trying to figuring out this thing. Whenever the traffic comes to a platform, who is exactly behind that, whether it is a human or it is a machine. We have been facing these problems. You might all have faced these problems of bot attacks. There was traditional bots which was there in this industry trying to scrape your data, trying to put your website down, and those were all the traditional bot. But with the new advancement now with the AI agent, I'm on the other side of the picture. When we wanted to use AI agent, we want to make useful out of it, and I'm completely in favor of that. But there are some adverse effects, there are some malicious actors out there who is trying to use it into a way to build the automation, to build the website down, to scrape the data, which is not the intent of a human buyer. Because when human buyer is coming on a website, they are not getting full fruit out of it because of these malicious activities which is happening. So yeah, I'll be diving deep into more what exactly is the need, how exactly we should be protecting our platforms, what are the different kind of mechanisms we should be looking into, which is our traditional mechanism, where and why that is basically not working anymore, and what are the shift we have to take at this particular point. So if you see this particular slide, over the last 2 decades, the assumption, every system, every detection system, pricing system, fraud system, the assumption has been always this thing that the website is there and the human will be interacting on that website. Every click means human. Interaction of the page is the engagement of that particular human, how exactly and what exactly they want on the particular website. But that thing is shifting completely now. I have mentioned 2026 here, but it's not like from past few years. Whenever the AI, all these automations are being moving to the AI agent, and the AI agent are easily able to mimic exactly the human behavior. They are able to move mouse, they are able to click on the pages, and they are exactly doing everything which the detection system cannot detect. Earlier, traditional bots were not doing that. They were directly coming to your website. There was no mouse movement. There was no clicks which was happening. And the tells were very easy. There were the surface level tells which we were able to use to detect those particular kind of agents. But here, the story is completely changing. Whether it is a human, it is a bot, or it's a mixture of both. That is the basic thing which we might need to look into and to understand how exactly it can cause an adverse effect to any of the platform. Okay, before moving ahead, I just wanted to ask a few things. How many of you has built any extensions or used any extension for any price tracking? It can be price tracking of a product. Whenever it goes down, give me a notification. Or maybe the flight tracker that, okay, give me a price when the flight prices are going down because currently it is showing me really high. Anyway, most of us. In that case, I wanted to say, you have successfully sometime developed a bot to somebody else's platform. And that is why you all are, I'm sorry to say this, part of this problem which I'm trying to explain over here. But yeah, actually, was it bad? Was your intent bad? I don't think so. Everybody wants less price. I don't want to pay anything extra for any of the product if I know that in future it might go below the price. So that is the hard problem which has to be solved here. The thin line between the user and the automation. It's not like automation is always bad. It is helping somebody, and at this particular point, we do not want to block, we do not want to take any actions where it is helping a genuine buyer. Whereas if it is a malicious actor which is coming to your website, that is where the concern comes in. Okay, so I'll move to our next slide, where you can see 3 types of actors which is available here. The traditional bot, fixed, predictable, boxy. They do not move anything. They are very predictable timing. Identical request path. No mouse movements are happening. No scrolls are happening. You are using some automation browsers to might be scraping some data or hitting multiple requests on what? One particular path with single IP, with a single user agent. You might be seeing in a fraction of seconds, millions of requests has been thrown. This is not the right request which is coming to your platform. Definitely it is not helping any of the human. That is what we are dealing with till now. The shift which has been happened is the second one, the AI agent. I believe this particular one went to the business school because this is really smart. Variable context aware timing, adaptive navigation flow, real browser events are happening. They are using real browsers, they are moving the mouse, they are moving the cursor, they are scrolling, they are clicking. All the tells which we thought till now is human is exactly the mimicking which is happening by the AI agent. And it adapts to the UI changes. In the traditional bot, when we were writing the static scripts to get the data, we wanted to see what all tags are there on the website. You have to hard code that tags. Okay, go and look for this particular thing and get me the information. As soon as the UI changes, that breaks. If you show a captcha or anything, that cries. It does not work with that. That story is getting changed over here. That it is able to adapt to the UI changes because it will read your whole DOM, provide to the LLMs on the behind which is working. It will take the decision and provide the response back to that, and it will be able to click or change, adapt very fastly with the change of UI, which is if you even change the UI too. And the third category, all of us. In one hand we have coffee, in one hand we have phone, thinking about maybe what will I eat, pizza or something, and then scrolling. Maybe Instagram, maybe your Slack app, maybe your email app. You wanted to do something, but as soon as you entered inside that app, something else caught your eye, and you went there, you start doing something else, and then, oh, let me go back, complete my task. That is you. That is completely different what AI agent and traditional bots are doing. But the uncomfortable part to me over here is that the in-between agent is more like human rather than more like traditional bot. And that is the place where we are losing our data, we are losing our platform, we are losing our resources of the platform, that it is going to the malicious actors overall here. Okay, so as the 3-4 things which I already mentioned, I have just mentioned in this particular slide, what all AI agents do at scale. They are doing the inventory scraping. You might be they might be looking into the product which is coming in, how many options are available. If the product has 10 options left, they will buy all 10 options. They will put all 10 options to the cart. The second and most dangerous part is the credential stuffing. That every day it is being growing because they are able to solve the captcha. They are able to handle the MFA prompts, retry intelligently over the stolen credentials. Earlier traditional bots were incapable of doing that, but they can do, and that's why the account takeovers are happening. Number 3, the scalping. Okay, tell me, there might have some time in your life where you wanted to buy something which is a hot deal, super hot deal, a sale event, where the event is coming and going out within a fraction of a second. You might landed on the page, you refresh the page, and as soon as the page will be rendered, the product is not at all available anymore. Why exactly is that happening? Because of the automations, the agents which have been working on the background, trying to put the data into the cart, or trying to put the product into the cart. Maybe not even buying it, but at this particular time, you are also not in get option to buy that. So loss at both the ends, to the platform owner as well as the end consumers. And large, the API abuse, it is basically on the consumer end. They do not try to perform any DDoS attacks or anything. They will not try to maybe doing any, they will try to be under the hood that they will not hit the rate limit. But they will extract the maximum value out of it. They will not break the website, but they will break the use case of that particular platform. Now the question arises, till now we have lot of development which has been done in the past multiple years on how we will be blocking traditional bots. Why exactly that mechanism is not working anymore? What is the problem which is having? Because we have built resilient systems over the past many years to block the bot attacks, to block malicious actors' activities to coming to our website. How exactly the AI agent is able to cross that particular wall which we have created? Till now, in maximum use cases, we might all have, if you have worked into that particular part, might be using the surface signal, the IP addresses, the rate limiting, the device type, the simple user agent. If the request is coming from a same user agent multiple times, it is a malicious activities or something. So we have created rules, we have created that wall. We might be generating more rules, but it is a rule-based engine which have created inside the wall that, okay, agents will, traditional bot will not be able to bypass this wall. But the AI agent today is easily able to bypass this. IP address, they can use any of the residential proxies, trivial, very easy to bypass right now. Multiple different IPs, IP rotation can happen. CAPTCHAs, as I already mentioned, it can be easily solved, maybe by vision models, which is like less than 3 seconds it will take, or even can have human farms, which will take fraction of cents to even solve those CAPTCHAs. User agent, 1 line of code, very easy to spoof, nobody takes care of it right now. And the rate limit, as I mentioned in my previous slide, they always perform under the hood. They will not hit your rate limit. They will not break any of the old detection which was already working for you. They will just bypass it intelligently. So, as I was explaining earlier, as a human being, we have an Instagram app. We open to search for something particular. But at the end, we might be doing multiple things. And at the end, oh, sorry, I came for some intention. I'll search that particular thing and go back. That is what the first slide shows. The distracted part, or finally the concluding part, that is our trajectory, that is our behavioral fingerprint which is happening right now. Whereas, if I talk about the AI agent, they will be task-based. If I provide any information to them, they will look at the task, extract the data, done. 0.3 seconds, the task has been complete. This is what the behavioral signal of an AI agent automation will be. So what is the shift that is required here? Till now, we have been looking only on the surface signals. But surface signals are not telling anything of the AI agent automations which are happening today. What we might need to shift is to the behavioral context. How exactly the behavior? Basically, we do not want to ask at the traffic when the request is coming, who are you? We are not anymore interested in the identity of it. What we are interested, how you will evolve, how you will unfold yourself over certain requests which will be coming on our website. And that is the behavioral signal we might need to look into to understand how exactly and what exactly is happening. Basically, remove the identity, focus on intent. Because as we were discussing earlier, sometimes the intent is not wrong. You are looking for the less price. You are looking for that automation, so that intent is correct. But if somebody is trying to make your website down, make your platform down, that intent is not correct. So we might need to shift our focus more on intent rather than finding out the identity who is calling that particular request. I just wanted to spend few minutes on this particular thing, how exactly a detection system in the real time look like. Because whatever we have discussed, definitely it is all our research which we have done and will be able to detect it. But in the real time, when the request is coming to a very high traffic, millions of requests coming per second, and at this particular high pace request, you have to detect into the near real time whether this particular request is servable or not. And that comes to major five particular platform. And first start with the session assembly. Session assembly is basically, it has been distributed to multiple nodes, multiple edge nodes where the requests are coming. One request come to one node, next request come to another node. And you have to take out, you have to create an image, you have to create a consolidated data about the whole journey of that particular session. So that looks easy. In theory, it becomes easy, but in practical, when the requests are distributed to so many nodes, it is tough to maintain that. But I would say that is more of a distributed system problem and not an ML problem at this particular time, but an important first step in the pipeline which we might need to build whenever we are building into the production system. Second, the feature extraction. You cannot use all the feature in the hot path. Here we are not talking about seconds, not even milliseconds. Here, almost in sub-milliseconds, we might need to take the decision whether the request is servable or not. And for that, the feature extraction has to be really quick. Whatever available in the request or some rolling window from the past few requests. You cannot check the whole history from somewhere, how exactly that particular request is evolving or anything. So it is very important to understand what all the features we might need to use as part of the feature extraction, which goes to your real-time classifier. The classifier is basically, again, has to take the decision as soon as possible. You cannot put large scale models, deep learning models, or any high detection systems into the hot path. That can be some of the outliers we might need to use. But in the hot time real path, it has to be very fast, sub-millisecond classification result which it has to be created. And one most important thing, we might need to move from the binary decision. Till now we might be saying true or false, bot or human, something and something. Binary decision might not work in this case because it's a mixture of multiple things which is happening. So maybe we might need to move it to probabilistic scoring system here. And that is what the last decision engine which comes into picture is that low score, I'm very confident it is a bot, we can take a block actions. Medium score, maybe bot, maybe not, let's throttle them. Let's do something else, bad experience we can throw to understand whether it is a good intent or not. Even a very low score, maybe we can show a challenge, a captcha into the background or something. These are the multiple things which we can do when we have a spectrum of scores, we have a spectrum of probabilistic output which is coming out, rather than just binary output. So that assumption is also going away, that binary output might not help anymore here. And the last and most important part is the feedback loop, the continuous monitoring training, which I think many people are under-inventing. I would say it's the most important part because labeled incident outcomes flow back into your training data set is the most important. AI agents are adapting very fast. They are moving, changing. And as soon as your particular detection system goes out into the production world, it will be reverse engineered. AI agents will be able to adapt it. They are really fast. And that's why your feedback loop is more important. Every time, keep on getting the new data, keep on retraining your model, whatever you are detecting, feedback again to your system to keep on updating yourselves to. And whatever I discuss as part of this 4 problems which we figured it out into the production environment, it is not like, in theory, we might not even seeing this. But when it comes to the production, we have to change a lot of things. So we also went to few papers, we looked into the few studies of the research environment which has been there. But that only made us help to reach to a particular state where we can build something. But when it went to the production, multiple things come in. That is, first is the adversarial evasion, that is the arm race problem, which I explained. They are evolving really fast. As soon as you deploy your secret sauce into the production, it will be reverse engineer. So you have to keep on retraining on that. The latency constraint which I mentioned, it is some millisecond which we might need to look into. So we have to be really fast into our detection into the real-time hot path of the request. Before going to the third one is most related to this thing. Tell me one thing. I'm assuming it might happen with all of you, but if not, raise your hand, that you are in your bank website or your email or somewhere, and suddenly due to some security reason you have been kicked out. And when you are trying to log in again into 1-2 attempt, it is not allowing you to get into that. And after suddenly the third request allows you to enter again into that app. Is that happen? Yeah, right. It happened multiple times with me. And that is the high cost. That is that at that particular time, my thought is basically, I'm a genuine customer. I have been using this app for multiple years, and that is why it is exactly happening to me. And that erosion of trust on that app, that is the high cost, and that is the false positive cost. There might be a detection system on that app where it has detected a human to be a suspicious actor. And that's why you have been kicked out due to the security reasons, assuming that you are an app, or you are a bot, but you aren't. That is the false positive cost a system has to bear. And in theory, again, whenever we develop a model, we focus more on accuracy, as best as accuracy we can get. But in the production life cycle, it completely changes on the asymmetric cost function. Sometimes false positive high rate is fine. Sometimes false positive low rate is we have to maintain. When it is a sale event, a peak event, at that particular time, it is more costly to block a human rather than allowing a bot. At that particular time, it's okay to allow the whole traffic because a lot of sales gonna happen. We cannot block a human just because of some false positive rate. Whereas on a regular Tuesday, it is fine. That okay, because we want more accuracy. So on a daily basis, event type in the real production environment, we might need to switch. We might need to keep on tuning these parameters. It's not only best false positive or some allowed percentage of false positive or best accuracy. That definitely is the hard problem to solve when it comes to the production environment. And last, the privacy aware signals. Definitely we have to be very ethical boundaries has to be drawn here, that every behavioral signal cannot be captured. We have to be very vigilant about that, okay, some signals, some aggregated signals, not all the granular signals which can be collected at this particular time. So there are multiple more, but I felt that these are the major hard problems which we have seen into the production environment and keep on trying to evolve around it. Okay, so this particular slide I wanted to zoom out and wanted to say it's the problem not only on one particular platform or anything, it's the problem of the whole web right now, where the attacks, it has been happening from past many years, but how fast they are evolving. On the one side, it's the human, where traffics are going on, human is doing all the requests. On the other side, we have discussed the fully automated request with the AI agents or anything. In the middle is the overlap zone of the mixed intent, where human and agent both are available at the same time on that particular request. What exactly to do at that particular time? And that is the part is majorly expanding over time. The human part is I am assuming many of you, almost all of you are using agents right now. You are automating your work. You are not doing all the tedious work every day. You might have created some automation already, as we were discussing, price tracking or filling out the forms, which are tedious form work if you have that particular work of everyday chores. So those automations you are trying to do with the AI agents now, but at the same time, you are also on the website. You are also trying to do manually few things with the agents are not able to automate or doing something wrong. So that particular mixture of request which is receiving is clearly expanding at particular time. And the major three implications which is happening right now because of that. First is analytics. Till now, if your system is completely analytics based on the behavioral signal, it is getting polluted with a lot of agentic requests. So we might need to plan in this way that that particular training model is not only human requests anymore. It has the combination of human and agentic requests. And as I mentioned, it is not just one platform problem, it is a problem for the whole web. And the third, exclusion is not the answer. As soon as the first thing comes in our mind, if it is a malicious actor, block them. If it is an automation, block them. That is not the right thing to do, as it can be a nice intent too. So we need to figure out from the behavioral signals or some other signals what exactly is the intent behind that particular automation, and if the intent is correct, we might need to allow them. Based on the intent, the decisions has to be changed now. Okay, I'm on the last slide where the three things I wanted to take you home. If in any case you are in this category, if you are trying to build something, you are trying to make your platform safe overall end to end, these are the three things we might need to look into, because it is a fastly evolving place right now and the things are being set up. We are building the system. Everybody is trying to build the new systems over. There is no pre-studies or pre-things which is available from past 10, 20 years that, okay, this is the proper mechanism which we can use. So the first and foremost thing which we have discussed, behavioral context beats over surface signal, IP, rate limiting, user agent, and all those things might still be useful. It's not like it is not useful, but not sufficient. Behavioral signals are more important during this particular time. Binary classification, it's dead. According to this particular problem, you have to come up with a probabilistic scoring mechanisms to understand different kind of score can have different meaning out of here. And the last, feedback loop, definitely it's important. Otherwise, our detection system will not work. It will not be in this competitive environment, because agents are adapting really fast, really well. And as soon as you put your detection mechanism out into the production, it will be very easy to reverse engineer too. So that is the most important thing. One last thing on the previous part, analytics, where I have mentioned it is affected. I have written this article and got published into the VentureBeat last week, which is specifically talks about how the analytics is getting polluted overall today, and what all the things we might need to look into. The whole talk basically, but specific to analytics, which can happen, and how exactly it is polluting our data sets, which we might need to clean up based on this particular new evolving things. That's all from me. Thank you.
All right, well, thanks so much. Do we have, I think we might have a couple minutes for questions.
Yeah.
Anyone?
Right, you take it.
I'll just let you call on people.
Sure, yeah, go ahead.
I'm sorry if I missed this, but what kind of models are you using to do this, or can you not say at the kill me or something?
Yeah, might not be able to say out of what all the things which we are doing, but majorly on very high level, I can say this, that as I was mentioning into the presentation also, in the real-time environment is a very lightweight models. So any models might be useful based on the use case, maybe logistic regression, tree-based models, GBDDs and all those things. But you can use large-scale models also if you have that much of data set, if you have different type of signals which is available, to build some analysis out of it, to build some signatures out of it offline. It cannot be into the hot part. So it's all depends what exactly you want to use. It's the hot path where in the request only, in some millisecond you have to respond back to the client over the browser. It cannot be the large scale model. You might need to do the very basic, simple, lightweight models over there. But it can have multiple signals generated from the offline models.
Could you describe that? I mean, I'm guessing that you probably have multiple different types of small, fast models based on place, geography, or mobile, desktop. Is that accurate?
Yes.
Say any more about that?
Sorry. Again, something confidential might not be able to share, but the crux is still the same. Based on the use case to use case, things get changed. Somewhere in some request, in some path, you might be allowed to take extra time. In some path, you are not allowed to take extra time to perform the inference. In some part, real-time inference might not be required. It can be an offline inference. So based on completely use to case to case, yes, we have multiple things running at multiple places and multiple different parts are happening.
Do you have any hope for Ticketmaster?
Sorry?
Do you have any hope for Ticketmaster?
I don't know. But yeah, I can understand your problem. It has been happening with me all the time, specifically with the Coldplay concert. Yeah.
So I mean, kind of following up with that, you mentioned that in the high sale moment, it's better to let the bots through than to block actual buyers. But what if the bots are going in and sitting on all of the inventory? Isn't that a worse situation because you can't sell to real people? Or?
100%, and I think I just took the high level out of it, but it does not mean that you completely close your detection system. So definitely the detection system will still be happening. We should still be detecting and blocking those particular malicious activities. It's just that if any of your system is generating high false positive rate and where you are okay in some days that, okay, as you went to your bank app, first request, you have been detected as a bot and you are not allowed to log in. Second request, maybe you are allowed to log in. At this particular time, if it's a sale event, at what we want, we might not even want that first request to even fail. So that is the part which we might need to tune just for the false positive rate. It does not mean that we are completely making our accuracy to zero. Accuracy is still high. It's just that false positive rate consumptions can be low.
Couple of kinds of agents that I'm thinking about. One is, okay, there's a stolen credit card and someone's using an agent to try and use that credit card as quickly as possible across a lot of different platforms. Another is you have a person who just is farming out their shopping to agents, right? Mm-hmm. And that's legitimate. So do you have a sort of philosophy around how to differentiate between different use cases for agents, and is that important? Because I imagine you do want to let agents in to shop on platforms as well.
Yeah, and that's the most important thing. We have to figure out, it's an evolving field. We are also evolving a lot of things. We are in the preliminary stage right now. But with this evolution, we want to understand the intent behind that request, which I mentioned. So basically, if we are seeing after 4-5 requests, somebody is really trying to buy something. It is not just wandering around, not doing anything. Or if we want to try at some places to check the buyer history, that, okay, have they ever bought anything? Have they even signed in ever? Or it is just like signed out account, they are just keep on wandering. And it has been a long time that a long trajectory has been there where nothing is happening. At this particular time, you might be blocking a genuine agent too, because it has been a long time that has not shown any intent of the right activities. It is just wandering around. So I'm just taking a random example out of it. I don't know at the end how the model gonna react, how the we have to train the models in this way, but at the end, whatever the output will be, we need to validate that too. So I cannot say after 4 requests or after 5 requests or after 6 requests, this detection will be happening. It can be any n number of things which can happen. But the whole point is to try to figure out the intent. If the intent at the end is coming out to be that, okay, it is malicious intent, we might need to take some action. But if the intent is coming out to be normal, for example, you are building an agent, you are running an agent, but in between you are also interacting on that particular website. So we are seeing very good human interactions also, which is happening along with the agent. The middle part, which I was saying, which is the high expanding part, that is completely normal. So the detection system will be able to tell that.
Cool.
Yeah.
Are there situations where you would not only want to just decide that, okay, you're a bot, but I'm going to let you in, but you're a bot who maybe seems to be shopping for something for your human, and so I want to actually amplify what you can do? Like if you seem to be looking for drones, then let me make it easier for you to find the other drones to do a comparison for your human. Like, are there situations that where you would amplify?
Not in my knowledge, but maybe somebody else, some other platform might be using and doing that. Basically, most of the recommendation system problem, which I'm not dealing with right now. So yeah, I don't know whether that is happening or not, but we are majorly on defensing of our system, not boosting up our sales or advertisement or anything. I'm not looking into that particular one. Yeah.
From an industry perspective, are you seeing collaboration between sites like Amazon and credit card companies, where perhaps this detection, the models that you're using in order to rank, the user or behavior activity might need to be similar between the two? You're seeing across a credit card, multiple purchase attempts happening in seconds. Amazon would be seeing the same thing. So is there collaboration happening?
Not in my knowledge. I don't know. Maybe if that is the plan, but I'm not aware of that particular thing. Yeah.
Thanks.
So this is the last question.
Yeah.
Yeah.
Is all of your training done with labeled data sets, or is there a place in this space for training on unlabeled data?
We have everything. There's not a specific one model which is being trained overall here. Multiple systems are working. Multiple models is being trained with structured, non-structured, just behavioral, just surface level, combinations of those. So everything is there. Yeah. All right, good. Thank you, everyone.